Jimmy Akin's Mysterious World is brought to you by the Star Quest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give. You're listening to episode 68 of Jimmy Akin's Mysterious World, where we look at mysteries from the twin perspectives of faith and reason. In this episode, we're talking about whether the Earth is flat. I'm Dom Bettinelli, and joining me today is Jimmy Akin. Hi, Jimmy.
Howdy, Dom.
In the ancient world, many people believed that the Earth is flat. But several centuries before Christ, the Greek philosophers began arguing that it is actually a sphere. Now, today, most people accept the idea that the Earth is a sphere, but some believe it is a flat disk. And the number of people who think so has increased in recent years as the idea has become popular on the internet. And that's what we'll be talking about on this episode of Jimmy Akin's Mysterious World. So, Jimmy, I understand there are a few initial notes we want to make. What are they?
The first one is I don't want to start from the position that you must be stupid if you believe in a flat Earth. This is the position that most people in world history have started from, for reasons that'll become clear, and most people in the history of the world are not stupid. I've also been contacted by various people who believe in a flat Earth, and I try to treat them with the same respect that I want to treat everybody else with. So we'll be observing the same practice in this episode of the show. Everybody gets treated with respect per the golden rule. Do unto others as you want them to do unto you. I specifically disapprove of the way the flat Earth community is often treated. In researching this video, I saw a lot of videos where they were just openly mocked, and that's not going to be happening here. Research for this episode also was impeded by Google's near monopoly on internet searching. Google downranks websites, and on its subsidiary YouTube, it downranks videos that advocate positions it doesn't like. And in researching this episode, I encountered Google downranking flat Earth web pages and videos. So if you search for flat Earth, you're going to get a bunch of anti-flat Earth stuff, even if you're trying to find their arguments. So I hope the flat Earth community appreciates the approach we're trying to take here. I would note the flat Earth community has individuals with different viewpoints. They aren't all the same. They have different views, some of which we'll be exploring. And in prepping this episode, I relied in principle on, or in a significant way, on arguments proposed by the Flat Earth Society. They're the most famous group dealing with this subject. And also I used arguments proposed by a gentleman named Mark Sargent, who is a famous representative of the viewpoint as well, but has some differences with the Flat Earth Society.
So what is the historical background for the flat Earth view?
From the perspective of an ordinary person on the surface of the Earth appears flat. And from a flat Earth perspective, they'd say, well, that's because it is flat. From a globe Earth perspective, it's because the Earth is so big that a person on the surface can't detect the curve, which is held to be too subtle to see. Either way, many people in the ancient world concluded that the world is flat, though they might differ about the exact shape. For example, some might say it's a disk, others might say it's a square. In the 400s BC, the Greek philosopher Parmenides mentioned the view that the Earth is round. He doesn't seem to have been the first person to propose this, but his writings do contain the earliest recorded mention we've got of the idea the Earth is a globe. The idea was then endorsed by other Greek philosophers, including Plato and Aristotle. Aristotle, in particular, proposed several arguments for the Earth being a sphere, and we'll talk about those later in the reason section. Around 240 BC, the astronomer Eratosthenes in Egypt used the shadow of the sun on the summer solstice to try to calculate the circumference of the Earth, which he said was about 250,000 stadia, which is about 11% off the modern estimate of 24,860 miles. Among the educated in the Greco-Roman world, the globe Earth idea became the received view. In the age of the church fathers, you will find some fathers supporting the flat Earth view. Those include Lactantius, John Chrysostom, and Athanasius. You'll also find others supporting the globe Earth view, like St. Basil, St. Ambrose, and St. Augustine. By the Middle Ages, the globe earth view was dominant in Christian circles, and that's why a common symbol of the period was a sphere with a cross on top of it, symbolizing the supremacy of Christ over the world. Now, you may have heard the opposite, that people in this period believed in a flat earth and that the church opposed the idea of a spherical earth, and that Christopher Columbus was doing something daring when he tried to sail west to China because everybody thought he'd fall off the edge. That's not true, though. This is a myth that was invented in the 19th century by the American author Washington Irving. He's the same guy who wrote Rip Van Winkle and The Legend of Sleepy Hollow. But in the 19th century, there was a resurgence of flat earth views. In 1849, the English author Samuel Rowbotham published a pamphlet called Zetetic Astronomy. Zetetic means a seeker. A zetetic is a seeker, so this is like seeker astronomy. Others in England and America began advocating the flat earth view. In 1956, the English sign writer Samuel Shenton founded the Flat Earth Society, which is the most famous group supporting the flat earth view. And in recent years, the internet has helped popularize the idea.
Let's talk about the theories then. We normally try to lay somewhat extensive groundwork before we get to the theories, but in this case, this issue is front and center. It's pretty apparent. So what theories are there about this?
Well, basically that the Earth is flat or that the Earth is a sphere. There are other theories that would say the Earth has a more complex shape, but we won't be going into those in this episode just for reasons of time.
Like that the Earth is a Mobius strip or something like that.
Yeah, or that it's that it is spherical, but we're living on the inside.
Ooh,
for example. Yeah.
Okay. I would love to talk about those, but we'll do that another time.
Another time.
So let's. What can we say about this from the faith perspective?
There are people who argue that the Earth must be flat because of various Bible verses. The argument is that if God's word is true, and of course it is, then these verses prove that the Earth is flat. They cite a lot of verses. Some are more useful for flat Earth supporters than others. And here we'll be looking at some of the more useful ones for the perspective.
Are there Bible verses that say the Earth is flat?
There aren't any verses that just come out and explicitly say the Earth is flat. There's no verse that says the Earth is flat. Sometimes flat Earth supporters will cite 2 Samuel chapter 11, verse 11, where Uriah the Hittite and his men are camping outdoors. In their own translations, flat Earth supporters will sometimes render his remarks as saying that his men are camping on, quote, the flat Earth, close quote. But the Hebrew phrase in question, al panei hasadeh, literally means on the face of the open land or in the open field. It doesn't mean flat Earth. This is both because panei doesn't mean flat. It means a face or a surface. And obviously, if you think about the shape of your own face, it's not flat. It doesn't have to be, the face doesn't have to be flat. Surfaces don't have to be flat. It's also not referring to the entire Earth, just the place where Uriah's men are camping out in like an open area like a field. So since there aren't any verses that say the Earth is flat, what flat Earth supporters who use biblical arguments do is point to Bible verses that they take as implying that the Earth is flat.
Okay. So what are some of those verses that they use?
In Job 38, verses 4 and 5, God asks Job if he was there when he laid the foundation of the earth, suggesting that the earth has a foundation of some kind. And it uses, this passage uses the verb yasad, which means to lay a foundation. In 1 Samuel 2:8, Hannah says that the Lord has set the earth on its pillars, using the word metsuke, suggesting that pillars are the kind of foundation it has. In Deuteronomy 28:49, Moses says that God will bring a nation against Israel from the end, ketseh, of the earth, suggesting that the earth ends at some point and has edges. In Isaiah 11:12, the prophet says God will gather the exiles of Judah from the four corners, arba kanpot, of the earth, suggesting that the earth is a square with corners. In Genesis 1:6, God says, let there be a firmament, rakia, separating the waters above from the waters below, suggesting that the earth is covered with a dome or a bowl. That's what rakia, which is often translated firmament, means. In Psalm 104, verse 5, the psalmist says that God set the earth on its foundations, though the Hebrew actually says he set it in its place, al hamekoneh. But he goes on to say that it will never be moved, suggesting that it doesn't move through space. Genesis 15:12 refers to the setting sun, suggesting that the sun, not the earth, moves. And Genesis 32:31 refers to the sun rising, again suggesting that the sun moves. There are other passages, but many of them just use the same phrases. We just went over, four corners or ends of the earth or sunrises. We won't be looking at such duplicate passages for reasons of time and also because multiplying examples doesn't fundamentally alter the argument. From a flat earth perspective, if one use of one of these expressions implies the earth is flat, then that proves the matter. And from a globe earth perspective, if one use of an expression doesn't imply the earth is flat, then multiplying additional copies of that expression doesn't prove the matter either, because they can all be explained the same way. So just piling up duplicates doesn't really alter the fundamental shape of the argument.
So are there Bible verses that globe earth supporters use?
Yeah, and in fairness to flat earthers, not all of the verses that globe earth supporters use sometimes are good ones. For example, Isaiah 40:22 says that God sits above the circle, hug, of the earth. And I've seen some people say, oh, see, if God's sitting above the circle of the earth, that means the earth is a sphere or a globe. But that's not what hug means. A sphere or ball or globe is a three-dimensional circle, and hug just means an ordinary two-dimensional circle. In fact, flat earth supporters sometimes use this verse, Isaiah 40:22, to argue that the earth is a flat disk, which actually would better correspond with the idea of God sitting above the hug or circle of the earth. But there are some verses that are better from a globe earth perspective. In fact, Isaiah 40:22, the same verse, goes on to say that God stretches out the heavens like a curtain and spreads them like a tent to dwell in, suggesting that the earth isn't covered by a solid dome or bowl, but by a tent-like structure. That's a different image that's being used here than in Genesis. Isaiah 13:13 says that God will shake the earth out of its place, suggesting it doesn't remain in its place forever. Revelation 20:11 says that at the great white throne judgment, earth and sky flee from God's presence, again suggesting that the earth isn't forever unmoved. Job 26:7 says that God hangs the earth upon nothing, suggesting that it's suspended in space rather than having a literal foundation. So very different image than the passages referring to the earth being on a foundation. In Job 26:7, the earth is hung upon nothing. So it's just like suspended in space.
Given these two differing sets of verses, how are we to integrate the different understandings that these verses propose?
First, we need to realize that the word translated earth in this passage doesn't quite mean what we think of as earth. The word is eretz, and it means dirt, ground, or land. It can be used as a reference to all the land everywhere, and thus the whole world, but you can't just assume that every time you encounter it, it's talking about the whole world. You have to ask what land or dirt or ground is in view in a particular verse that uses eretz. Also, we have to ask how literally these different expressions we've looked at are meant to be taken. Most of the passages are drawn from either poetic or symbolic books like Job and the Psalms, which are poetic, or books like Isaiah and Revelation, which are prophetic and are known for using symbols and figures of speech. This means that we have to be on the lookout in considering these passages for non-literal modes of expression. The ancients used figures of speech and symbols just as much as we do, if not more. For example, in the standard English translation of Exodus 34:6, it describes God as being merciful and gracious, slow to anger, and abounding in steadfast love and faithfulness. But the phrase slow to anger isn't what it literally says in Hebrew. What it really says in Hebrew is God is long of nose, He's got a long nose. And long of nose was a Hebrew figure of speech that meant patient or slow to anger. So that's just an illustration of how, if you take something literally, it's not going to mean what the author's really trying to communicate in a good number of cases. And the books of the prophets, are famous similarly for using obvious symbols like the image of a shoot springing from the stump of Jesse as a symbol of the Messiah. But obviously, Jesus is not literally a plant. Hebrews had a highly literary mode of speech, and so we can't simply assume that these verses would have been understood by the original audience as literal statements. Also, you get absurdities when you try to take all these verses as literal descriptions of the world. If the earth had four corners, that was one of the phrases from the four corners of the earth, well, then it would be a square, but then God couldn't sit above the circle of the earth. So which is it? Is it a square or a circle? Also, if the earth is covered by a solid dome, then the heavens can't be stretched out like a tent. And those were also two phrases we saw. If the earth is set on a foundation made of pillars, then it can't be hung on nothing. So the Bible uses different images to picture the world at different times, and they don't all match up, indicating they can't be pressed literally. Further, we need to read each verse in context to figure out what the author is really trying to say, because in none of these verses is the author trying to give us a geography lesson. He's not trying to describe the physical shape of the world we live on. He's talking about something else. And so you have to say, well, what's he really trying to say here? And you look at, for example, Deuteronomy, where God says he'll bring a nation against Israel from the ends of the earth. Well, he just means a distant land. This is a prophecy of invasions from places like Assyria and Babylon. If the Israelites disobey God, then he's going to let their neighboring rivals invade them. He's not talking about an army coming from Antarctica, and at which flat Earth supporters will hold is at the end of the earth. They'll say it's a big ice ring, ice wall around the edge of a disk, typically. And he's not talking about that as the end of the earth. He just means a distant land like Babylon or Assyria. He's not talking about an invading army from Antarctica. And thus, he's not implying that the earth literally has an end. Similarly, when Isaiah says that God will gather exiles from the four corners of the earth, he just means all the lands they were scattered to as a result of the Babylonian exile. He's not saying that the earth literally has four corners, but there are, four directions, north, south, east, west, and God's going to gather the exiles from those places. The statements that the earth can't be moved are meant to show the power of God. That's really what's under discussion in these passages, because the earth can't be moved by human means. No man is able to move the earth. So this shows the solidity of God's work, because man can't undo it. It doesn't mean that God can't move it or that it's literally motionless. In fact, Hebrews knew about earthquakes because Israel is a seismologically active area. The Levant has volcanoes and it's got regular earthquakes. In fact, the Bible refers to earthquakes that happened in biblical times. And, of course, prophecy does say that the earth one day will be removed by God's power. Finally, we need to recognize the particular kind of figure of speech that's often present in these passages. It's the fancy term for it is phenomenological language, or describing things according to the phenomena or the appearances. From a flat earth or from an earthbound perspective, if you're standing on the surface of the earth, the sun does indeed appear to rise and set. It was thus natural for the ancients to describe its motion according to the phenomena they saw. It does appear to move and thus has apparent motion. But even globe Earth supporters use the same language, talking about sunrise and sunset without meaning that it's the sun that moves and the earth is stationary. Similarly, when Isaiah refers to God sitting above the circle of the earth, he's using phenomenological language. From an earthbound perspective, the horizon appears to be circular as you turn around 360 degrees. And that's what Isaiah is referring to, the circular horizon. He's not commenting on what shape the earth may have beyond the horizon. He's just describing God sits above the horizon of the earth that we can see. Ultimately, the Bible verses that flat earth supporters use don't prove what they would like. They're mostly found in poetic or prophetic texts that are heavy in non-literal modes of speech. They use different and incompatible images to picture the earth, like the earth alternately having a foundation or being hung on nothing, and that means we can't press them as literal descriptions. They also use phenomenological language that describes things according to the appearances without being positive assertions that there's no greater reality behind the appearances.
So from the faith perspective, we don't have to be flat earth supporters.
No, as the Catechism of the Catholic Church says in paragraph 283, why don't you read that, Dom?
Many scientific studies have splendidly enriched our knowledge of the age and dimensions of the cosmos. These discoveries invite us to even greater admiration for the greatness of the Creator, prompting us to give him thanks for all his works and for the understanding and wisdom he gives to scholars and researchers.
So, from a Catholic perspective, the Church doesn't have any problem with the findings of modern science about the world.
All right, that was the faith perspective. What can we say about this from the reason perspective? What evidence do flat earth advocates cite for their perspective?
Many start with personal experience. If you go out into a non-mountainous region like Kansas or the open ocean and you look around, the surface of the earth around you appears to be flat. Unless evidence to the contrary emerges, you would be entitled, like most people in world history, to extrapolate the flatness you see and conclude that the earth as a whole is flat. That would be a reasonable conclusion, and many people in history have done just that. But we also need to ask whether the globe Earth hypothesis would account for this effect, and it does. The Earth is so huge, with an equatorial circumference of just under 25,000 miles, that its curve on the globe Earth theory would be very, very, very gentle. That would mean that from the perspective of a human standing on its surface, you couldn't see the Earth's curve without precise measuring tools. And even those, in most situations, are going to be thrown off by local variations in the height of the ground, like hills and mountains, or by things that obscure the horizon, like trees and buildings. So this means that both the flat Earth and the globe Earth hypotheses will account for why the Earth looks flat from the perspective of a human standing on its surface.
So then how can we distinguish between the two theories from the reason perspective?
People on both sides of the discussion make a large number of arguments, and frankly, far too many for us to list here individually. So for both flat Earth supporters and globe Earth supporters, I apologize if I omit some of your favorite arguments. We need to keep this episode at a reasonable length, so we'll only be able to focus on some of the major arguments that the two perspectives make and then discuss those.
Okay, so what's one of the major arguments, and how do the two groups view it?
Flat Earth supporters often appeal to a series of events known as the Bedford level experiment. These were carried out on the Old Bedford River in the United Kingdom at various points in the 19th and 20th centuries. Famously, one of these experiments was done by a flat Earth supporter named Samuel Rowbotham in 1838. He's the guy that wrote Zetetic Astronomy. The Old Bedford River has a 6-mile stretch where it's a straight line, which makes it a good place for taking measurements if you look down that straight line path of river. Here's what Rowbotham said about the experiment in Zetetic Astronomy.
If the Earth is a globe and is 25,000 English statute miles in circumference, the surface of all standing water must have a certain degree of convexity. Every part must be an arc of a circle. From the summit of any such arc there will exist a curvature or declination of 8 inches in the first statute mile. In the second mile, the fall will be 32 inches, in the third mile, 72 inches, or 6 feet. After the first few miles, the curvature would be so great that no difficulty could exist in detecting either its actual existence or its proportion. In the county of Cambridge, there is an artificial river or canal called the Old Bedford. It is upwards of 20 miles in length and passes in a straight line through that part of the fens called the Bedford Level. The water is nearly stationary, often completely so, and throughout its entire length has no interruption from locks or water gates of any kind, so that it is in every respect well adapted for ascertaining whether any or what amount of convexity really exists.
And when Rowbotham looked down this stretch of river, he didn't see the drop-off that was needed according to his calculations. And so he concluded that the Earth is not a sphere.
So how do Globe Earth supporters respond to this?
By pointing out that Robotham made some mistakes in his calculations. First, he used an incorrect formula to compute the curvature of the Earth. The formula he used said that the curvature of the Earth will be 8 inches times the number of miles of distance squared. That's how he got the figures that it should drop off 8 inches after 1 mile, then 32 inches after the second mile, and 72 inches after the third mile. He can't be blamed for using this formula because he got it from an article on leveling from the then current edition of the Encyclopedia Britannica. And normally, the Encyclopedia Britannica is a reliable source, but this formula is incorrect. For the curvature to be based on the square of the miles, the Earth would have to be shaped like a parabola, kind of like the top skinny part of an egg, except it would fall away forever with an ever-accelerating downward slope with no curving bottom to the egg. And that's not what Globe Earth supporters hold. They hold that it's a sphere, and so the true formula is not based on the square of the distance, but on the cosine of the distance divided by twice the radius of the Earth. You can see why the square formula he used is incorrect, because the square numbers always increase. Every square number is bigger than the last one. So if you think through the squares, 1, 4, 9, 16, 25, 36, 49, 64, and so on, they just keep getting bigger. And so that would mean that the Earth would keep falling away more and more with every mile. It would never bend back on itself, and you'd never have a South Pole. So you just have this ever-accelerating slope away from you. And weirdly, whatever point you were standing on would be the North Pole, because and that would make no sense. I mean, if I'm here, if I'm at the old Bedford, and I'm standing here, and the Earth falls away with this amazing accelerating slope away from New Bedford, then I would be living on the slope here in San Diego, and I wouldn't see it fall away in the same way as old Bedford because the Earth wouldn't be a sphere. So it's clear this formula based on the square of the distance is not accurately describing the shape of a globe Earth. For something that would bend back on itself, you need a mathematical function that oscillates like a sine or a cosine, not square numbers. So to calculate what you'd see looking at the curve of the globe Earth, you need to calculate what's known as the SAGITTA, or the amount of rise that you would expect between you and a distant point. That would be the hump. The SAGITTA is the height of the hump of the Earth that should be between you and that distant point as the Earth curves. We'll have the actual SAGITTA formula in the show notes. You know, it's obviously kind of hard to read it here on the air and have people understand
Wouldn't do any
it.
good. Right.
Yeah, but we'll have it in the show notes. And in examining the formula for the SAGITTA, I didn't take anybody's word on it, since their formula, if I just read it on a web page somewhere, it could be just as wrong as the formula that Robotham got. And so I worked my way to this formula. I confirmed it with various websites, but I worked my way to this formula from basic trigonometric principles. So I verified for myself this is correct. The upshot is that you won't see nearly as much curvature as Robotham thought you would. After 3 miles, you would not see the same kind of drop-off, and after 6 miles, you wouldn't see the drop-off he predicted. Robotham's calculations were also affected by the fact he didn't fully take into account the effect of atmospheric refraction. Refraction is what you see if you put a spoon or a straw in a glass of water and it looks bent. That's because the water bends or refracts the light. Well, the same thing happens with air. It also bends light compared to what light will do in a vacuum. And Robotham didn't fully take that into account. So in 1870, the philosopher and naturalist Alfred Russel Wallace, who was a qualified surveyor, reran the experiment with the correct calculations, and his results showed the curvature that you would expect if the Earth is a globe. And similar experiments have shown the same thing. In fact, last year in 2018, I wish I'd known about this at the time, there was a parallel experiment run on another big flat body of water, the Salton Sea, which is just a few miles from where I am in San Diego. It's down in Imperial County. It's America's Dead Sea. It's the lowest body of water in North America. And it stinks. And as I know from personal experience, because I've been out there a number of times, and if I had known that they were having a flat Earth, globe Earth off out at the Salton Sea, I totally would have driven out for that. So they had both flat Earth supporters and globe Earth supporters together running this experiment on the Salton Sea, and the results showed the expected curvature of the Earth.
By the way, if you go to Google Maps and you Google Old Bedford River, you can look at the street view of that and get a view of the long straight stretch of the Old Bedford River that Robotham was using. So that's a nice illustration of what we're talking about. So
cool.
What's another of the major arguments that is offered?
We wouldn't be doing due diligence if we didn't look at some of the famous arguments that the Greek philosophers in the ancient world proposed. So we'll be looking at several that were proposed by Aristotle, who lived in the 300s BC. In Book 2, Section 14 of his work De Cielo, or On the Heavens, he proposed several arguments, and here's one of them.
Its shape must necessarily be spherical, for every portion of Earth has weight until it reaches the center, and the jostling of parts greater and smaller would bring about not a waved surface, but rather compression and conversions of part and part until the center is reached.
I find this fascinating because even though he didn't have Newton's equations for gravity, Aristotle is essentially making the same argument that many modern people do, that the Earth is so big that its gravity, the gravity holding together its parts, will naturally pull them into a round spherical shape. And here we have Aristotle making exactly that argument 2,300 years ago.
So how do flat Earth supporters respond to this argument?
From reading different flat Earth authors, it seems that they generally deny the theory of gravity, that objects with mass naturally attract each other. They then replace gravity with something else, such as a hypothesis that objects naturally fall down and only down, not towards another object that has mass. So, for example, if you drop an apple on Isaac Newton's head and it falls down, it isn't falling towards the Earth because the Earth has mass. It's just falling down with respect to a universal frame of reference, and Isaac Newton's head and the Earth just happen to be lower in that frame of reference. So it's not the Earth's gravity and the apple that are pulling on each other. It's just things fall down. This means that flat earthers need to reject major components of the last 300 years of physics. They need to reject both Newtonian physics and Einsteinian physics, since both deal extensively with the theory of gravity. This also has big implications for astronomy, because Newton's and Einstein's equations for gravity describe the motion and formation of planets, stars, and galaxies. These are also the same equations that we use to send space probes to other planets and astronauts to the moon. Consequently, some flat Earth supporters believe that NASA is engaged in a huge conspiracy, that it doesn't really send probes to other planets, and that the moon landings were faked. And we'll, of course, be talking about the moon landing hoax theory in a future episode. So being prepared to reject major portions of modern physics and astronomy, as well as modern space exploration, seems to be needed to avoid the force of gravity argument that Aristotle and physicists since then have proposed.
What's Aristotle's next argument?
It's based on the moon and what we see during lunar eclipses. Aristotle says,
"The evidence of the senses further corroborates this. How else would eclipses of the moon show segments shaped as we see them? As it is, the shapes which the moon itself each month shows are of every kind, straight, gibbous, and concave. But in eclipses, the outline is always curved, and since it is the interposition of the Earth that makes the eclipse, the form of this line will be caused by the form of the Earth's surface, which is therefore spherical."
Now, it's important to note what Aristotle is saying here. He argues that the Earth is spherical because it casts a round shadow on the moon during lunar eclipses. He doesn't say it's spherical because it casts a round shadow on the moon during its monthly phases. it's a common misconception that the moon's monthly phases are caused by the Earth's shadow, but they're not. They're caused by the angle from which we're seeing the moon and how much of its surface the sun is lighting from our perspective. But when the Earth's shadow falls on the moon, that's when we have a lunar eclipse. And Aristotle knows this, and he distinguishes it from the monthly cycle we see on the moon. That's why he says we can see different shapes of shadows on the moon during the monthly cycle, sometimes even a straight line separating the light part and the dark part. But in a lunar eclipse, the segments of shadow are always round, according to Aristotle, because the Earth is round.
And how would the flat Earth supporters respond to this argument?
It depends. Not all flat Earth supporters have the same view. This is one of the points on which they differ. Some are prepared to say that essentially everything we see in the night sky is a simulation, like what you'd see in a planetarium. On this view, what we see doesn't have any physical reality. It's just a projection or image of some kind. So the Earth isn't casting a shadow on the moon during a lunar eclipse. That's just an image we're being shown. This is the view of Mark Sargent in his book Flat Earth Clues, where he writes,
all eclipses in the enclosed world model are artificial, like they would be in a planetarium, which is really what you're in, a giant planetarium combined with a terrarium. There is no Earth between the sun and the moon, so everything you see displayed in the sky, that being the sun, moon, stars, and planets, are part of a fantastic display system.
Incidentally, this is also Sargent's solution to the fact that we can see other planets in the solar system rotating on their axes, revealing that they're spheres. So if you buy a cheap telescope from Amazon, you can go out in your own backyard and watch Mars rotate or see Jupiter's red spot move across its surface and come back on the other side. For Sargent, this is all just part of the sky's fantastic display system, but it has no physical reality.
Do all Flat Earth supporters agree with this?
No, the Flat Earth Society thinks that other planets are real, and they think that they're spheres. They argue that the Earth is the exception to this rule, and in their FAQ, they respond to the question, why would Earth be the only flat planet, by saying,
this betrays a logical fallacy. Karl Popper relates it like this. You may spend your whole life seeing only gray geese. This would lead you to assume that there were only gray geese. Of course, the next day you might wake up and see a white goose. Earth, in this analogy, is the white goose.
So we're special on their view. All the other planets, like Mars and Jupiter, they're spheres, they rotate, but we're a flat disk.
So how do Flat Earth supporters who reject the planetarium theory deal with lunar eclipses?
The logical move for them is to say it's not the Earth's shadow that causes lunar eclipses, thus allowing the Earth not to be a globe. For example, the Flat Earth Society has a page that argues it can't be the Earth's shadow because sometimes you can see both the sun and the moon during a lunar eclipse. But if they're both up in the sky, then the shadow we see on the moon can't be the Earth's.
Well, that sounds like a good point. How do Globe Earth supporters respond to that?
They point out this is a real phenomenon. It's known as a selenelian or a horizontal eclipse. It can occur only at sunrise or sunset when the sun is just above one horizon and the moon is directly opposite it at the other horizon with the Earth in between. It's typically really hard to see a selenelian, but you can if you go up on a mountain just at the right time. From altitude, the refraction or bending of light caused by the Earth's atmosphere, the same effect you see with the spoon or straw in a glass of water, that'll bend the light enough to allow you to see both the sun and the moon for just a few minutes before one or the other drops below the horizon. So the globe Earth view can account for this effect.
I remember recently the Smarter Everyday YouTube channel guy had a video of this that he took. He traveled to Australia, I think, recently. It was, or I'm not sure if the travel was recently, but the video was recently that showed just that effect that you mentioned. So that's interesting.
Yeah.
So what's Aristotle's third argument?
It's based on what stars you can see depending on how far north or south you are. He says,
quite a small change of position to north or south causes a manifest alteration of the horizon. There is much change, in the stars which are overhead, and the stars seen are different as one moves northward or southward. Indeed, there are some stars seen in Egypt and in the neighborhood of Cyprus, which are not seen in the northerly regions, and stars which in the north are never beyond the range of observation. In those regions, rise and set.
So Aristotle is right here that there are stars you will or will not see, depending on how far north or south you are. For example, if you are below the equator, you will never, at any time of year, see Polaris, the North Star. Similarly, if you're north of 40 degrees above the equator, you can't see Alpha Centauri, the closest star to our own solar system, because Centaurus is a southern constellation. That means our Canadian friends are out of luck because Canada is above 40 degrees north latitude. And I hate to break it to you, Dom, but Boston is at 42 degrees north latitude, so you can't see it either from there. But fortunately, at 33 degrees north latitude here in San Diego, I can see it at least during part of the year. Aristotle's argument regarding stars is part of a more general issue, which we can call the horizon problem.
So what's the horizon problem?
Basically, on a globe Earth, you would see things sink below the horizon, and the curvature of the Earth would block them from your view. As they sink, the horizon would cut them in half, and then you wouldn't see them at all once they fell below it. Now, Aristotle's argument about stars deals with the case of how far north or south you are, keeps them below the horizon, and thus unviewable from certain locations. It doesn't really deal with them being cut in half as they sink below the horizon, because stars are too small in the sky to really see them cut in half as they sink. They're so small that just blip and then they're gone when they go under the horizon. But other things are big enough and close enough to see them get cut in half. A famous argument is that if you're out in the open ocean and you see a ship sailing away from you, the ship doesn't just dwindle in the distance. The bottom part of it vanishes first, so that you'll still see the top of its mast even after you can't see the body of the boat, because the curvature is blocking the bottom of the boat from your view. Similarly, if you're sailing towards a big city, you'll see the tops of the tallest buildings come up over the horizon before you can see the bottoms of the buildings. Or if you're watching the sun or the moon, either rise or set, you'll see them cut in half by the horizon as they go up or down. But you wouldn't see those things on a flat Earth. Instead, you'd see a ship sailing away from you progressively shrink as it got farther away, but you wouldn't see it cut in half by the horizon. Conversely, you'd see the buildings in a distant city grow in size, but you'd see the whole of the buildings all at once, not just the tops. And you would similarly expect the sun and the moon to get larger or smaller, but not cut in half as they rise or set.
So how do flat Earth supporters respond to this?
In different ways, depending on the case. In the case of ships vanishing over the horizon or buildings coming up over it, they often deny that this is what happens. Here's what Mark Sargent has to say about things disappearing over the horizon.
They don't. They just reach the vanishing point of your natural vision. There's some great footage online of boats that can't be seen with the naked eye, but become visible once the zoom is activated. Then they disappear past the limits of the zoom, and yet another camera can reacquire the ship. This isn't possible with what we are told about the curve.
And here's what he has to say about the sun and the moon rising and setting.
The sun and the moon do not set in the enclosed world model. They just move further away from you, continuing their very long circle above the disk.
Now, you might raise an objection at this point and say that if the sun and the moon just moved further away, they would just grow and shrink in the sky, but they wouldn't vanish. You might see a little spark for the sun as it moves really distant, but it'll never really vanish. I can think of two responses that someone coming from the flat Earth perspective might make. First, if the sun and the moon were small enough, they might just shrink to the point you couldn't see them, like a ship or a building in the distance. Or second, they might be like spotlights, shining down on particular areas, but not visible if you're not under them. How if you see a spotlight shining down from, say, an auditorium ceiling from the right angle, you don't see the light itself because you're viewing it from the side, but the people who are standing directly under the spotlight could see the light.
You might address this later on in your notes, but two things come to mind. One, do some flat Earth supporters believe that the sun and the moon go underneath the disk and come up the other side?
My understanding is some of them do, but
not necessarily a mainstream or large.
Yeah, so there's a problem with that, which I do mention a little bit later on. Okay. The problem with that is if that was what happened, then it would be night for everyone on the Earth at the same time.
Okay.
Because the sun would be below the Earth, so nobody would have daytime.
And the other thing that comes to mind is
and sunset would happen at the same moment, and sunrise would happen at the same moment for everyone.
That's right. Okay. The other thing that came to mind was someone standing at the North Pole or the South Pole from a globe Earth supporter's point of view at the right time of year would see the sun go around the horizon, as they say, and would not necessarily behave in this way, right? The getting smaller.
Yes, from a globe Earth perspective. Okay. But for now, let's look at
let's move on from
perspective.
Right. I just those came to mind. So, and we can bring them up later. How well do flat Earth responses to the horizon problem work?
I don't think they're successful. You will find pictures on the internet that flat Earth supporters use to argue that ships and buildings don't really vanish or appear over the horizon. You can find situations where the use of a telephoto lens or where atmospheric refraction, that bending of the light, will help keep an object in view longer than you'd expect if you didn't take that into account. But these are cases where the object isn't so far away that the horizon is having a clear effect. On the other hand, there are cases where if the object is big enough and far enough away, you will clearly see the top of a ship or the top of a building peeking up over the horizon when you can't see the bottom of it. The horizon effect on the sun and the moon is even more striking. They're very big and they're very far away, and they are clearly cut in half by the horizon. If you're in a flat place, like out on the ocean or whatever, and you watch the sun come up, or even in Kansas, you will at first see the light of the sun peeking over the horizon, but you won't see the solar disk. So King Akhenaten is going to be very disappointed. But then you will see the solar disk, or Aten, start to peek up over the horizon. Then you'll see a larger and larger portion of the disk. And then finally, you'll see the whole sun. But that's not what you'd see on a flat Earth model. If the sun and the moon were small enough to vanish in the distance, but stayed above the horizon, then we'd see them dwindle to tiny dots or expand from tiny dots, but we wouldn't see them cut in half. If they were like spotlights shining down, then you'd see them at progressively more tilted angles as they moved away, or less tilted angles as they moved closer. This would mean that at dawn, you'd first see a thin little line for the sun that then became a narrow oval, and then a thicker oval, and then an almost circle, and then a full circle. Just like you'd see a spotlight as an oval if you're looking towards it at an angle in the distance. But you wouldn't see it as a full circle that is cut in half by the horizon. Also, if the sun was a spotlight shining down, we'd have a problem explaining how the planets in the solar system are lit, assuming they're real, because the angles involved indicate that a huge sun is shining on them from the center of a vast solar system, not a tiny sun hovering close in above a flat Earth that's just spotlighting down on it. In fact, I don't see how the planetarium model of the sky that Mark Sargent advocates would account for this, because if you're seeing the sun cut in half by the horizon, then everyone in the world should see the sun cut in half by the horizon, since we'd all just be seeing the same projected image from the sky, just from different distances. Right. And again, sunrise and sunset would happen for everyone in the world at the same moment.
So thus far, we've been focusing largely on arguments that people in the ancient world could have made. But today, we can fly high above the Earth in airplanes and spacecraft. So if the Earth is a globe, then at some altitude, its curvature should become obvious, and people could get in planes and just fly up and observe it. What has our ability to reach these altitudes revealed?
The extreme case is presented by photographs of the entire Earth taken from the moon or from space probes, and they do indicate a spherical shape. The standard response I've encountered from flat Earth supporters is that these pictures are fake, meaning that NASA and other space agencies are involved in a huge conspiracy to cover up the fact that we're living on a disk. Flat Earth supporters also argue that we've never been given a non-composite picture of the entire Earth, that satellite photos taken from low Earth orbit are composites of different high-altitude photos that have been stitched together to make the Earth look like a sphere. And while some photos are composites, not all of them are. There are also photos from orbit that, even if they don't show the entire Earth, a single photo will show the edge of the Earth and show it's got a spherical shape. Some of these photos are even available in real time, coming down from weather satellites. But, Flat Earth supporters can still claim they're computer-generated fakes. Just you have to expand the conspiracy somewhat. The problem that we have here with the space photos is that most people don't have access to spacecraft and satellites at this point. Though once the space tourism industry gets started, that'll start to change. So let's look at an industry that far more people have access to: airlines. I reached out to a friend of Mysterious World, Captain Jeff of the Airline Pilot Guy podcast, and here's what he had to say about the visible shape of the Earth at airline altitudes. Welcome to the show, Captain Jeff of Airline Pilot Guy. First, a question about you. How long have you been flying? I believe you have both a military and a commercial career.
Yes, I started flying in the early 80s. Went through Air Force undergraduate pilot training in 1982, beginning of 83. And I flew C-141B cargo transport aircraft for a couple of years. And then the rest of the time I was an instructor pilot. That was a total of little over 7 years in the Air Force. And then I was hired by a major legacy airline back in December of 1988. And so coming up this year, this December, will be 31 years of commercial airline flying. I have over 20,000 hours of flying time.
Wow, so quite a bit of experience. At what altitudes do commercial airliners typically fly?
The greatest concentration would be in the probably 30 to 35,000 foot range.
Okay, so about 6 miles up.
Yes.
And how high does aviation go these days?
Well, some of the corporate business jets are up in the 50,000 foot level. Anything higher than that would have to be something military oriented, like a U-2 or an SR-71, but or the Concorde when that was flying.
Now, obviously, visibility is a big issue when you're up at altitude. There can be cloud layers and things that obscure the horizon. But on a clear day at commercial levels, like the 35,000 level, do you see, looking out the front window of the cockpit, do you see the curvature of the Earth, or do you see it not being curved?
Well, of course, yes, I see a slight curvature. Of course, this is also amplified when you get up to higher altitudes. For instance, when I was in the Air Force flying the T-38, we got up into the mid-40s, and you could definitely see more of a curvature. Again, because the Earth is quite large, it's not going to be something that is really pronounced, but you can definitely see that there is a curve from that altitude.
So at commercial altitudes in the 30s, it's not as obvious. So you could be a flat Earth supporter or a globe Earth supporter and be a passenger and kind of look at it either way, but it becomes more obvious at higher altitudes.
Exactly.
He also discussed how airline pilots have to use their onboard radar to compensate for the curvature of the Earth, particularly when tracking weather systems at night. Here's what he had to say.
When we're trained to use airborne weather radar, we are warned that one of the risks is that if you set the tilt of the radar antenna that is in the nose of your airplane up too high, you could overscan weather. And so it's tilt moderation or management is very important in my line of work, because we don't want to, especially if you're flying at night and there's not a moon out to throw light on things. You're basically flying blind, except you're relying upon the weather radar to see thunderstorm hazards. And so you have to make sure that you are keeping the tilt at a level that allows for you to see the potential hazards in front of you. But we can, if we see like lightning way off in the distance, I mean, you see flashes of lightning, not bolts of lightning, but like the sky, you see the like sheets of lightning sometimes, like the sky lights up, but you don't really see bolts, individual bolts. Well, we can see that at night way off in the distance. And the reason why we don't see the bolts is because it's beyond the horizon and beyond the curvature for our line of sight.
Like a sunset.
Exactly. But, like a flashing momentary sunset. In that scenario, let's say I see it on the ground-based radar quite a ways off, couple hundred miles. I see the flashes in the sky, but I can't actually see the thunderstorms themselves or the lightning bolts coming from the thunderstorm until we get a little bit closer. And we're now, the curvature of the earth is such that my line of sight is now I can see that thunderstorm hazard.
So as you're flying, you can see that there's something over the horizon, but the curvature of the earth is blocking it from you. And then as you get closer, you no longer have that big hump of earth in front of you anymore. And so you can see it now.
That is correct.
So based on Captain Jeff's experience, the curvature of the earth is real and can be detected from the altitudes that commercial and military planes get up to.
Are there other problems with the flat earth model?
One has to do with circumnavigating the planet or traveling around it. Flat Earth supporters frequently hold that as we mentioned, that the Earth is a flat disk, and at the center of the disk we have the North Pole, but there is no South Pole. Instead, there's a vast ice wall at the edge of the disk, and this is what Antarctica is. It's not a compact continent, but it's a huge ring stretching around the entire disk of the Earth, and you can see that in the cover art for this episode. So what does it mean to circumnavigate the planet if it's not a globe? How can you start in one spot, travel in one direction, and come back to the same spot? According to the Flat Earth Society's FAQ page,
circumnavigation of the Earth is simply traveling a circular path around the North Pole.
So if you were 1 mile from the North Pole and you circumnavigated, you'd make a really small circle, just over 6 miles. In circumference based on the 2 pi r formula we all learned in geometry class. If you were 10 miles away from the North Pole, you'd fly in a circle just under 63 miles in circumference, and the distances would keep getting bigger the farther away from the North Pole you were and the closer to the Antarctic ice wall you were.
And are there any problems with that?
I can think of two. The first is that you aren't really traveling in a straight line. If you do this, I mean, think about being 1 mile from the North Pole. If a plane was flying from west to east, towards the rising sun, the pilot would have to keep turning left to make that tight 6 mile circle. So he's not really traveling in one direction or a straight line. He has to keep turning, and he'd have to make a conscious act. He'd have to take conscious action periodically to turn left to keep coming back to the same spot. And that would be true no matter how far away from the North Pole you were. In order to do a circumnavigation, a pilot would have to keep turning left. The same thing would be true if you were flying between two cities that are on the same latitude. For example, San Francisco, California, and Richmond, Virginia are both about at the 37.5 degree latitude north of the equator. And so if your pilot was flying between those two cities, he'd have to make these leftward adjustments to his course to fly on the 37.5 parallel to get from San Francisco to Richmond. And if he didn't make those, if he just went straight between one city and the other, then in the middle of the trip, he'd find himself too far north. He'd maybe find himself over South Dakota instead of Kansas. And he would notice that because he's not following that parallel. He's just cutting straight across. So he's going to go across a more northerly region. So I asked Captain Jeff about this, and here's that part of our conversation. On a flat Earth, circumnavigating the world would mean flying in a circle around the North Pole. So if you were a mile from the North Pole, then based on the 2 pi r formula we all learned, you'd have to fly in a 6 mile circle. And if you were flying from west to east, then you would have to, as a pilot, keep turning left or to the port in order to make that 6-mile turn. Otherwise, you just keep flying away from the North Pole. Am I right about that? You'd have to turn in this circle?
Yes.
Okay. So the same thing would be true if you're at some greater distance and if you were flying due east along some latitude, along some parallel, like if you were traveling along the 37th parallel, say from San Francisco, California to Richmond, Virginia, both of which are about at the 37th and a half parallel. You'd have to do the same thing. You'd have to keep turning left in order to make that circle and stay on that parallel around the North Pole. If you didn't, then in the middle of the trip, you'd notice, wait, I'm too far north. I'm not over Kansas. I'm over South Dakota or something. Mm-hmm. When you fly long distances, and I know you do, but when you fly long distances along a parallel, do you or other pilots, do you have to make these leftward or portward turns, or do you notice if you don't that you're too far north?
If we were to, say, fly from San Francisco, if we received clearance, which probably would never receive, direct from San Francisco to Richmond, Virginia on the 37th parallel, unless it's in the middle of the night and there's hardly any other traffic, they may clear you as soon as you're up at cruise altitude. They may say, proceed direct to Richmond. And if that happens, the true heading would be constant throughout your track from the San Francisco area to Richmond.
So you're not adjusting the direction to fly in a circle.
Right, you're not.
And you don't look out in the middle of the trip and say, wait, I'm over a state that's too far north.
Right. That is correct.
So that's one problem with the flat Earth model. Pilots say they don't adjust course to stay on a certain parallel, and they don't find themselves over the wrong area when they don't adjust their course.
All right, so what's the second problem with circumnavigating the planet?
It has to do with travel distances in what globe Earth supporters call the northern and southern hemispheres. On a globe Earth, the longest circumnavigation is going to be at the equator. That's why in episode 66, Amelia Earhart wanted to fly as close to the equator as she could so that her circumnavigation would be longer than anybody else's. But on a flat Earth, points below the equator or farther from the North Pole are going to take longer to circumnavigate. To do the longest circumnavigation, you'd want to fly as close to the Antarctic ice wall as possible. This got me to thinking about the distances involved in circumnavigating in the northern and southern hemispheres. I ran the numbers, and if you pick a random point in the southern hemisphere, it will on average be 3 times farther away from the North Pole than a random spot in the northern hemisphere. So you think about that. If you're at the North Pole, you're 0 miles from the North Pole. If you travel halfway to the equator, you're 3,000 miles from the North Pole. If you travel to the equator, you're about 6,000 miles from the North Pole. Halfway past the equator, you're 9,000 miles from the North Pole. So the average spot in the northern hemisphere would be 3,000 miles. The average spot in the southern hemisphere would be 9,000 miles. So 3 times farther away. And that would mean that on average, circumnavigating in the southern hemisphere would take 3 times longer because the circle would be 3 times bigger based on the 2 pi r formula. If you make the r 3 times bigger, then the circumference is going to be 3 times bigger.
Okay, so let's take plane trips in the northern and southern hemispheres and see how long it takes us to circumnavigate the world.
I went on Travelocity.com and I looked up flights between cities in the northern and southern hemispheres. I tried to make them as close to the North and South Poles as I could using major airports. That way we'd have a good test for the flat Earth hypothesis. If we use really northern and really southern airports, then it would show a big difference in the travel times. Then I put the flight times, the amount of time you'd spend in the air, into a spreadsheet and added them up. So let's fly and see how long we would travel to circumnavigate the northern hemisphere. We start in Vancouver, British Columbia, and we fly to Halifax, Nova Scotia, both cities in Canada. We're flying on WestJet, and it takes us 5 hours and 28 minutes. We then leave from Halifax to Reykjavik, Iceland on Air Canada. We fly for 4 hours, 41 minutes. We then go from Reykjavik to Stockholm, Sweden on Iceland Air. That's 2 hours, 55 minutes. We go from Stockholm to Moscow, Russia on Aeroflot. That's another 2 hours, 10 minutes. We then go from Moscow to Beijing, China, also on Aeroflot. That's 7 hours, 30 minutes. And then we go from Beijing back to Vancouver, British Columbia on Air Canada. That's 10 hours, 35 minutes. So our total flying time to circumnavigate the Northern Hemisphere is 33 hours, 19 minutes. Now let's fly the world using airports on what globe theorists call the Southern Hemisphere, so farther from the equator on the flat Earth view. We start in Sao Paulo, Brazil, and we go to Johannesburg, South Africa on South Africa Airways. That's 8 hours, 25 minutes. We then go from Johannesburg to Sydney, New South Wales in Australia on Qantas. That's 11 hours, 45 minutes. We go from Sydney to Santiago, Chile on Qantas. That's 12 hours, 30 minutes. And then we go from from Santiago back to Sao Paulo, Brazil on LATAM Airlines, and that's 3 hours, 50 minutes. Total flying time, Southern Hemisphere, 36 hours, 30 minutes. So for the Northern Hemisphere, we had 33 hours, 19 minutes. For the Southern Hemisphere, we have 36 hours, 30 minutes. That's a difference of only 3 hours and 11 minutes. And the difference is because the Southern Hemisphere is less populated. 90% of the Earth's population lives in the Northern Hemisphere. So with 9 times more people, you expect 9 times more international airports in the Northern Hemisphere. And so I had more choices to connect. I didn't have to deviate as far from the latitude I was aiming for. But in the Southern Hemisphere, the population's less. There are fewer international airports, and I just could not avoid Sao Paulo, Brazil. I wanted direct flights from Santiago or Buenos Aires, which are farther south, but everything kept pulling me up to Sao Paulo, which is considerably closer to the equator. And that meant a detour, and it ended up adding 3 hours to our flight time. That 3 hour, 11-minute increase is only a 10% increase. It's not the 300% increase that we should see if the Earth were flat. And the only reason for that 10% is because of fewer international airports below the equator.
So 300% would have been an additional 300 hours of flight time, give or take.
Basically,
right?
yeah. It should have taken like 330 hours or something like that.
Which is a couple weeks. So, yeah. Okay. So can we show other problems with the flat Earth model using commercial aviation?
Yeah, one of the things I noticed on the flat Earth maps is that Perth on the west coast of Australia is almost 180 degrees opposite Tierra del Fuego at the tip of South America. You can see that in the episode art for this episode. They are actually 183 degrees apart, so it's almost 180, almost directly opposite on the globe. On a globe Earth, the shortest distance between Perth and Ushuaia, Argentina, that's in Tierra del Fuego, the shortest distance on a globe Earth would be 6,438 miles, and you'd get there by crossing the South Pole. On a flat Earth, though, the shortest distance between Perth and Ushuaia is 18,464 miles, and you'd get there by crossing the North Pole. So that's the shortest distance. You're not trying to circumnavigate by flying on an angle. You're just going directly over the North Pole to get from Tierra del Fuego to Perth. The average maximum speed of a commercial airliner is 510 knots or 587 miles per hour. And at that speed, it would take 31 hours, 27 minutes to fly from Perth to Ushuaia. So let's fly. There aren't any direct commercial routes over the South Pole, presumably because not a lot of people want to go from Tierra del Fuego to Perth. But Travelocity.com will let us book a flight from one city to the other with 3 stops. First, we fly from Ushuaia in Tierra del Fuego to Buenos Aires on Aerolíneas Argentinas, and our flying time is 3 hours, 35 minutes. Next, we fly from Buenos Aires to Sao Paulo, Brazil, which we again cannot avoid, on Aerolíneas Argentinas, flying time 2 hours, 55 minutes. Then we fly from Sao Paulo to Johannesburg, South Africa on South African Airways, flying time 10 hours, 35 minutes. And finally, we fly from Johannesburg to Perth on South African Airways, flying time 11 hours, 15 minutes. Total flying time from Ushuaia, Tierra del Fuego to Perth, Australia, 28 hours, 20 minutes. Notice that our flying time is less than the fastest possible commercial time on a flat Earth, which would be 31 hours, 27 minutes. Those are close, though. I mean, it's only 3 hours difference, so you might chalk it up to inexactitude of calculations or conspiracy, that they're hiding it from us, that you're really going over the North Pole to do this. But there are problems with that view. The first one is the stops we make on the trip. There are 3 stops in Johannesburg, Sao Paulo, and Buenos Aires. None of these is in the Northern Hemisphere. But you'd have to fly over the Northern Hemisphere to make this trip. Specifically, you'd have to fly all the way up South America from Tierra del Fuego, across the Caribbean, across North America, over the polar ice cap, across eastern Russia, across part of China, and down to Perth. These are not things that your conspiratorial pilot and flight crew could hide from you. Most of your trip is over land, not water, which it would be if you took the route I described, connecting, going over to Johannesburg in South Africa and so forth. Most of that circuit's going to be on water. So most of your trip would be over land, and you'd have this huge North Polar ice cap field in the middle of your trip. And you could look out of your window and see that. Also, Johannesburg is in South Africa, but if you went to Africa, it would dramatically lengthen this trip. And during your stopover in Johannesburg, you'd really be in Johannesburg. You could leave the airport and, tour the city for a few hours or days. You'd know that in the middle of your trip, you were really in South Africa, not at the North Pole. So this would tend to falsify the airline conspiracy theory because they couldn't hide that. And so I also asked Captain Jeff about this, and here's that part of the discussion. If someone is circumnavigating the world in the southern hemisphere, then the trips would be much longer because you'd be farther from the North Pole on a flat Earth. And on average, it would be about 3 times longer. But commercial air routes for the southern hemisphere don't reveal that they take any longer than circumnavigating in the northern hemisphere. And you also, at stopovers, you could verify I really am where I'm supposed to be. So I'm not like taking a shortcut over the northern hemisphere, to keep the travel times the same. Some flat Earth supporters, though, argue that the announced routes are deceptive and that planes really are taking a direct route over the northern hemisphere. For example, if you wanted to get from the tip of South America, Tierra del Fuego, to Western Australia, where Perth is, then on a flat Earth, the shortest route would be up over South America, then over North America, over the polar ice cap, down eastern Russia and China, and finally down to Perth. So most of that route would be over land rather than water, which is what would happen if on a globe Earth, you'd fly either over the Atlantic or the Pacific to get from one to the other. And there would be the polar ice cap in the middle of the trip. So wouldn't this require a big conspiracy among airline pilots and other airline flight crews and staff members that would be really hard to keep under wraps? It seems like there would be, thousands or tens of thousands of people who would be in the know that these flight routes were deceptive. And it would seem that, at least after they retired, there would be whistleblowers, wouldn't you think?
Oh, yeah, absolutely. I know a lot of airline pilots, and there is absolutely no way that if this was actually occurring, it was some kind of a deception, which I really don't understand what the deception would be for, actually.
To hide the fact we're living on a flat Earth.
Okay. Again, I really, it's hard for me to understand that, but, right now, just in the just at my airline, there are over 14,000 pilots. And American Airlines and United also have equivalent amounts, probably over 60,000 licensed airline transport pilots here just in the United States. That's not counting the rest of the world's pilot population. Among that number, no one coming out and saying that this is actually what's happening and this is all a big deception, I find that highly
implausible.
Yeah, implausible. Thank you. Good word.
Mm-hmm. Yeah. So wouldn't passengers notice that they're flying over land rather than water and then spot the polar ice cap in the middle of the journey and know that the route was bogus?
Mm-hmm.
I mean, that's something that you, even if you're not a pilot looking out the front window, you could look out the side windows and see, hey, there's a lot of land down there, and now there's a polar ice cap, and now there's more land.
Right. Yeah, exactly.
Excellent. So, Jimmy, what is your bottom line on all of this?
As I hope this episode reveals, I wanted to give Flat Earth supporters a fair shake, just like I want to give everybody else a fair shake. But ultimately, the arguments for their position don't work. To adhere to a Flat Earth model, you'd have to reject too much. You have to reject the idea of gravity, including Newton's and Einstein's equations, which have been repeatedly verified, including by high school and college students in their physics labs. You'd have to either say that the night sky is a colossal projection, or that for no clear reason, Earth is the only planet that's not flat.
That is flat.
That is flat. You'd thus have to reject major parts of physics and astronomy. You'd have to reject easily verifiable facts, like the fact that the horizon really does cut things in half, like the sun, when they sink or below it or rise above it. You'd have to imagine that there are colossal conspiracies involving tens of or hundreds of thousands of people, involving the airline industry and all the space agencies that different countries have. You'd have to reject the fact that it's possible to fly around the southern hemisphere in the same time it takes to go around the northern hemisphere. And you'd have to reject the fact that you can fly from Perth to Tierra del Fuego in 28 hours without crossing North America or the North Polar ice cap. And that's just too much for me to reject. Occam's razor tells us to accept the simplest solution, and the simplest solution is that the Earth is a globe. And I'll let Captain Jeff have the last word today. How confident are you, based on your now 3 decades of service as a military and commercial pilot, how confident are you that the Earth is a globe rather than flat?
I would say 100% confident that it is a globe. In my experience, as you said, almost 4 decades now coming up.
Oh, right.
That I've been flying. It is very clear to me, and I'm 100% confident that we are living on a sphere.
Okay. Well, thank you very much for joining us, Captain Jeff.
You're very welcome. It was my pleasure.
All right. Thank you, Captain Jeff, and thank you, Jimmy, for all of that wonderful analysis. It's really, I never thought of it, and to giving this a fair shake, the flat Earth, and I'm glad you did so, because it really it helped. Even though I wasn't a flat Earth supporter before, I think having that information is an education in itself, and I appreciate that. So I'm really grateful. What are the further resources we can offer to listeners who want to find out more about this?
The first one is, we'll have in the show notes the correct formula for calculating a SAGITTA based on the cosine function instead of the square function. We'll also have Nathan Roberts' book, The Doctrine of the Shape of the Earth, which focuses on religious arguments. We'll have Mark Sargent's book, Flat Earth Clues. We'll have Gordon Brooks's book, he's a Globe Earth supporter, so his book is called The Earth is Not Flat. We'll have an article from popsci.com called 10 Easy Ways You Can Tell for Yourself That the Earth is Not Flat. We'll have a link to the Flat Earth Society's homepage so you can see what they have to say. We'll have a link to Mark Sargent's YouTube channel so you can see what he has to say. We'll have a link to the book Zetetic Astronomy. Also, Wikipedia's discussion of the Bedford level experiment and the Skeptical Inquirer's discussion of the Salton Sea experiment. We'll have articles on atmospheric refraction. We'll have a calculator for calculating sagittas. We'll have a counterproof of the 8 inches per mile squared formula that was used at the Bedford level. We'll have a calculator for the curve of the Earth, and then also the source code, if you really want to dig into it, for the curve of the Earth calculator.
All right, so let's move to our mysterious feedback from our listeners on our previous episodes. This feedback will be coming from our discussion of La Salette. And the first one comes from Stephen by email. He says, I have a copy of Bishop Ullathorne's book purchased in the gift shop at the shrine, which I've not yet read. I'm so glad that your latest episode was this apparition. You told me many things that I never knew. I always assumed that this apparition was authentic without any knowledge one way or the other. This makes me very eager to get to the book.
Yeah, and hope you like the book, Stephen. Bishop Ullathorne is a supporter of La Salette. He's a big supporter of it, so he takes a somewhat more positive approach than the conclusion we arrived at. But by all means, everybody's arguments need to be considered, so do check his out.
Kathy on Facebook writes, "This was an excellent episode, very fair and honest, as Jimmy's always is. It was fascinating hearing all that goes into making judgments about such events. These were far from perfect kids, but on the other hand, God sometimes seems to prefer lesser messengers. Fascinating either way. Thanks."
And thank you, Kathy. I was really pleased and gratified at how positive the feedback we got on this episode was, because since we couldn't come to a fully positive conclusion and say, yeah, La Salette, definitely go, 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 I was concerned that, people might have a negative reaction to that. But I guess in trying to be fair and balanced, we've attracted a fair and balanced audience, and they appreciated the approach we took.
At the risk of pandering, I think we have the best audience. Adam Hovey on YouTube writes, "I have a question. What would you say to the people that claim Marian apparitions are satanic and the like? I'm Catholic, so obviously I don't believe that, even though I do believe some of the purported apparitions are false, like Bayside."
So I think it depends on a couple of things. One of them is there are people, and this is particularly true in the Protestant community, there are people who just don't believe in Marian apparitions, and their first thought is going to be to attribute Marian apparitions to Satan. Frankly, I'm like, well, why not hoax? That's an option too. Or imagination. There are several options. Don't automatically go for the devil. There's multiple sources of error in the world, and he's just one of them. Don't give him too much credit. But really, it's for theological reasons. It's because they don't agree with the Catholic faith, and so any supernatural phenomenon that would tend to support the Catholic faith must be part of a deception. And it's natural from that point to attribute the deception to Satan. So that's why that phenomenon happens. It's just a straightforward deduction on their part. Having said that, there is such a thing as a false revelation that comes from the devil. We read about this in the New Testament on more than one occasion. St. Paul talks about how we need to test the spirits because not every spirit is from God. And also we're told the devil clothes himself as an angel of light. And so, there is such a thing as demonic revelation. We got to be on our watch about it.
All right, so Father Jeff on Facebook writes, "I noticed you mentioned that Lourdes occurred shortly after this. One of the reasons the Sisters of Nevers were so strict with St. Bernadette was that they knew what had happened with Melanie, who had already left at least one convent, and were determined not to let it happen to Bernadette."
Thank you, Father Jeff. That's an interesting perspective. I hadn't heard that, but that certainly could shed light on what happened with the apparition at Lourdes.
The Internet Peasant writes on YouTube, "I'll always remember Marjo Gortner from Star Crash."
Yeah, Marjo Gortner, who we mentioned in this episode, was a religious charlatan who then outed himself and did a documentary about himself as a charlatan, and then became an actor and starred in the sci-fi camp fest Star Crash, which, if you're interested in Star Crash, you might want to check out the Mystery Science Theater 3000 episode on it that came out on Netflix a couple of years ago. And you can see Marjo Gortner and the rest of the sci-fi schlock extravaganza with added commentary from the Mystery Science Theater crew.
Oh my, that's just like a mashup of so many great things.
Yeah.
Cody and Elijah write by email, "My son and I love listening to Jimmy Akin's Mysterious World. Anytime we're in the car, we listen together and have some great conversations about your show topics. He turned 8 last week and had a little birthday money. He decided to donate it to SQPN. Keep up the good work."
Wow, that is so awesome.
Yes, very humbling too.
Yeah, that someone who's 8 would want to support the show in that way with their birthday money. All I can say is happy birthday and thank you so much. What a great kid, and keep listening. Hope you enjoy the show, and thank you so much.
Yeah, my 8-year-old son Anthony loves it too, so that's great. Jimmy, what are some mysterious headlines for the listeners this week?
Well, since this week we were looking at a scientific mystery of, whether the Earth is flat or spherical, I thought we'd look at a couple of scientific mysteries for mysterious headlines. The first is a woman's blood turns blue. And not because she marries into a royal family, literally blue.
Wow.
And so we have an article on why that happened. Also, gut bacteria can make people drunk without them drinking alcohol.
Wow.
There is a condition known as autobrewery syndrome, where your gut bacteria will metabolize things into alcohol inside of you.
Wow,
So
that seems like a cost savings.
Well, yes. Unfortunately, it is real alcohol, and so it can cause liver damage if autobrewery syndrome gets out of hand.
Yeah, that's right. I make a joke, but yeah, it's serious. Jimmy, in a second, I'm going to ask you what our next episode is going to be about. But first, I do want to take a moment to thank our patrons who make this show possible, including James D., Wyland F., Renee J., Daryl F., and Frank L. Their generous donations at sqpn.com/give make it possible for us to continue Jimmy Akin's Mysterious World and all the shows at StarQuest. You can join them, like Cody and Elijah did, by visiting sqpn.com/give. So, Jimmy, what is our next episode going to be about?
Our next episode is this month's patron-requested episode, and the patrons have asked to hear about Pope Joan.
All right, so that's it from us. What did you think about this discussion of the flat Earth? Let us know by visiting sqpn.com or the Jimmy Akin's Mysterious World Facebook page, sending us an email to mysterious@sqpn.com, or sending a tweet to @MYS_world with the hashtag of mysterious feedback. Be sure to check out the Mysterious World bookstore at mysteriousworldstore.com for links to all the books and videos that Jimmy mentions in the show, and all your purchases there help support the show, and we get a little portion of it, and it helps us continue. You can find links to Jimmy's resources from our discussion and links to the mysterious headlines on our show notes at sqpn.com/mysterious. Until next time, Jimmy Akin, thank you for exploring with us our mysterious world.
Thanks, Dom.
And once again, I'm Dom Bettinelli. Thank you for listening to Jimmy Akin's Mysterious World on StarQuest.